So you see the problem here, and I'll try and be efficient so you can work through this. But the idea with this problem is that you have a plane going against the wind and a plane going with the wind. And so I have the problem here on the left. The x value is going to be the rate or speed of the jet, and y is going to be the rate or speed of the jet stream. So think about going with the wind, how fast the plane goes. You're going to add the speed of the jet plus the speed of the wind. That's going with the wind. And when you're going against the wind or jet stream, the speed of the jet will have to subtract, because the wind going against it's going to decrease the speed that it's going. So those are two ways to calculate how fast it actually is going, is you either add the wind or subtract the wind. Now the thing we've got to figure out is, how do I use the values here given in the problem to calculate the actual rate. So we're going to have to use these numbers here, and we'll start by just writing down the time, how long it's going. So for 7 hours is how long it's flying. Now there's a formula that we need to understand, that the distance, and this goes for anything, not just planes, distance equals rate times time. Sometimes you'll see it, distance equals rate times time. This is true for anything. If I want to find out, let's say I'm traveling at 40 miles per hour for 3 hours, I could calculate that I've driven 120 miles. So we can use it for any situation. And in this case, the distance that we've traveled when you're going with the wind is 5,453 miles. The rate would be x plus y, and you're traveling that for 7 hours. When you're going against the wind, the distance was 4,403 miles, again for 7 hours, and the rate, you're going to have to subtract the wind from the jet's original speed. So using these, obviously we can't solve for both the equation or both variables at the same time. What I can do, I can try and isolate these variables. So to do that, I can just divide by 7 on both sides. And this goes for both equations. And when I do that, when I divide by 7 on both sides, I'm going to get 779 equals x plus y. And when I divide by 7 here, it'll be 629 equals x minus y. At this point, I can use a process called elimination. And what you'll notice is when I add these two equations together, maybe I'll start writing a different color so it doesn't get too overwhelming, hopefully. As I add these two equations together, positive y minus y is just 0. So those cancel out. And that's the whole idea with elimination. That's why it's called elimination. X plus x is 2x, and 779 plus 629 is 1,408. And this helps us because now I can simply solve for x. This, maybe I'll just put it right here, this is the rate of the jet is 704, let's see, miles per hour. Now with that information, I've got two equations here that can help me figure out what the other is. And so I see that 779 is equal to x, which we know now is 704, plus y. So by subtracting 704 from both sides, I will be able to calculate that the rate of the jet stream is 75 I should put the units, 75 miles per hour. And that last process we call substitution, substituting in to find those values.